If you could take air out of the room, which wouldn't be a good situation for us, if you could take the air out of the room, then everything would drop together, whether it be a feather and a book or a feather and a hammer would both drop the same if there weren't any air. All right? And what happens is that when I drop something, right, what happens? It starts out, it doesn't have any speed, and as time goes on, it starts to speed up, doesn't it? So it's not like if you're just walking, if you're walking at like a constant just pace, you're just walking, right? I'm not speeding up, I'm not slowing down, I'm just walking, right? When you drop a book, it doesn't just at the same speed the whole time, right? It starts to get faster and then faster and then faster and faster. If you actually model that mathematically, it's a parabola. It does the same thing a parabola does. And we discovered that, we being humans, thank you for the book, we discovered that all objects on Earth will fall at the same rate if there's no air, and there's a parabola that will model that behavior. And I'm going to give you the actual equation that we use, all right? That works for being on Earth. So this is the equation we use for falling objects on Earth. No air. Now, I know you're going to sit there and be like, well, what the heck is the use of a formula that doesn't incorporate air into it? I mean, we obviously have air. Well, the way it works is this. It's kind of like a baby, you don't get a baby and just ask the baby to run, right? They have to crawl, and then they have to, walk, and you know what I'm saying? There's a process. And so in physics, what we do is we start off with the most basic equation, the easiest one to work with. And the easiest one to work with when you talk about objects falling on Earth is the one with no air. If you want to put air in there, the equation's going to get more complicated. And you have to build up to that, all right? So we are looking at this situation kind of like the baby is crawling right now, all right? So here's the equation. It looks like this. No, I get to make this up since it's not in your packet. I can use whatever letters I want. H equals negative 16 t squared plus v, put a little subscript 0 under that, t plus h, and then put a little subscript 0 under that. And I'll explain what all these things mean. Just write that down. And next to this, or up here, I'm going to write this. And what I want to point out to you is that what you're looking at here is the same thing as here, with the exception of, I'm just using different letters. So look, you see the t squared here? In the t, that's the x, okay? That's the x squared in x. Y'all got that? Also, for this particular problem, for objects falling on Earth, this right here is a. It's always negative 16. And believe it or not, that negative 16 has something to do with the gravitational acceleration on Earth. If you were to go to a different planet, then you would have the same formula, but that number would be different. So if you go to the moon, that number you don't have as much gravity on the moon, so that number would be smaller. Make sense? If you go to a bigger planet with more mass, then that would be a bigger number. So do you see that we already have these pieces? The H is really the what? The H is the Y, okay? The H is the Y. And then the only thing left is that little V with this subscript 0 and this H with the subscript 0. And I'll tell you what those mean. H with the subscript 0 means your initial height. And the word initial, you can replace it with starting if you want. It's easier to understand. So if I'm going to drop an object on Earth, right, then I'm going to have to maybe tell you what the height was when I dropped it. Was it 5 feet off the ground? Was it 100 feet off the ground? That number, whatever it is this number right here, which corresponds to the C in the problem. All right? You with me? All right. V naught is your initial speed. Initial or starting speed. So I'll try and explain how this number, which corresponds to the b, doesn't it? It's just the number in front of x here. It's the number in front of t. That accounts for the following situation. If I take an object on Earth, let's say it's 5 feet high, this would be 5, okay? And I just drop it. Then the starting speed is 0 because I'm just letting it go. Compared to this situation where I take it, instead of dropping it, I throw it down. Okay, if I throw it down, then I'm giving it an initial speed. Okay, when it comes out of my hand, it has speed to it, as opposed to just being dropped. Understand? That number represents how fast I was throwing it out. And then I could also have this situation. Instead of me throwing it down, I could throw it up. Okay? That would also change that number. And the way we do it is this. This number will be positive if up and negative if down. So you can almost look at it like if I had a gun here, right? Well, then that wouldn't be good. But in a year, I might be able to. In the new gun laws, but you wouldn't know that, would you? Okay, so let's say I had a gun here, right? Let's say I had a gun here and I shot a bullet straight up into the air, right? Then it would come out of this, as soon as it left the barrel, it would have a speed, and whatever that speed was, maybe it was 1,000 feet per second, was how fast that bullet was traveling. I would put 1,000 here. Positive 1,000, because it's going up. If I took that gun, I turned it down and shot down, then the bullet's going to be going down, same speed, 1,000 feet per second, I would put negative 1,000. Understand? Okay. Now, what does the t mean in the problem? Well, t is time, and it's measured in seconds. And there's only one letter out there still I haven't told you about, and that's the h on the other side. H is the height. It just got real fruity smelling in here. Height after, or I'll say not after, I'll say at t seconds. At exactly t seconds. What the? I mean, I don't even have time for a quiz. This is ridiculous. I know y'all want to do the quiz. I'm going to give you a take-home quiz. How about that? I'll do a take-home quiz. All right. So, you ready to try this real quick? We're going to try, it's about 7 minutes. I'm going to give you a word problem, and let's see if we can use this to figure it out. All right? This equation gives us how high an object is at exactly the time t, but you have to tell me two things first. What was the initial speed of the object, and how high was it off the ground when it started falling? Got it? All right. So what we're going to do is we're going to take, I'm going to be nice to you all. I'm going to keep this clean. I'm not going to be morbid here. A rock is dropped from a 1,200-foot building. Yeah. Yep. So there's someone standing on a 1,200-foot building looking down, and they get a rock and they're going to drop it. All right? And there's nobody down there. All right? It's safe. Okay. Find, this is part A. Find the parabola which models Situation. It's the first thing. Find the parabola that does it. Next thing I want to know is how long does it take rock to hit the ground? You ready? That's it. That's all I'm going to ask for this problem. So first, the parabola. We are going to assume that this is an object that's falling on Earth, and we're going to just neglect air for now. So the model that we're going to use is the formula I just gave you. So for part A, the answer would be, I need to rewrite this formula, but I need to fill in the V naught and the H naught. So let's start with V naught. Was this rock given an initial speed? Was it thrown down or just let go? It appears it was just dropped, right? So V naught is what? 0. So V naught is 0. How about H naught?
1200.
I was 1,200 feet, right? So 1,200. By the way, if you go back, remember I wrote down H naught? And I said initial height, put on there in feet. I forgot to put in feet. This formula works for feet and seconds. If you want to go to a different unit like miles per hour, the formula has to be changed a little bit. All right, you good? So H naught is 1,200. Okay, that's it. Let's rewrite the formula. The formula says H equals negative 16 t squared. What if V naught is 0? What is this whole thing? It's gone, right? So all I have is plus 1,200. There it is. That is the model for the situation. That's the model. That's the answer to part A. Part B, how long does it take to hit the ground? Well, think about it this way. This is a parabola, isn't it? Which way does it open? Down, right? It opens down. And the y-intercept is 1,200. Do you agree? The y-intercept is 1,200. Because, and what that corresponds to is if this is time, at time is 0, I should be up here, right? The rock is about to be dropped. And as soon as time starts, what should happen? Start coming down, right? So my parabola should do something like this and hit somewhere, right? What we want to know is how much time, because this axis is time, how much time went by before it hit the ground. So that really corresponds to what, from what we've been doing. Finding this point is really finding the x-intercept of this, right? So this second question is really asking you to find the x-intercept of that graph. How do we find the x-intercept? We set y equal to 0, right? But in here we don't have y. We have h instead, right? So what I'm going to do is I'm going to say for part B, how long does it take to hit the ground? Okay, let h be 0. When h is 0, I'm on the ground, aren't I? That's the height. The height is 0. I'm on the ground. So I'm going to replace in here 0, and I'm going to solve this for t. So let's solve that for t. It's 0 equals negative 16 t squared plus 1,200. That's a quadratic equation, right? T is the variable. Which of the cases do we have? Are we missing the x term? Are we missing the constant? Or do we have all of it? We're missing that x term. It's really the t term, right? We're missing that t term. We have a t squared, but we don't have a t. How do we go about solving something like that? That's if we were missing a constant term. This is the other one. This is where all you do is isolate the t squared. Get it by itself. So move the 1,200 to the left side, and it becomes negative 1,200 equals negative 16 t squared divide by 16, so you're going to take 1200 and divide by t square by 16, pardon me. Negative 16, you should get 75 is equal to t squared. You got that? And the last thing is square root. And you should get two answers, plus or minus 8.66, about. T is about positive 8.66 or negative. Remember, if you take the square root on both sides, do you remember that? If you take the square root on both sides, you have to do plus or minus. So on our graph, this was 1200 up here. It comes down, it hits here, this is 8.66. But that was time, right? So it should be 8.66 what? Seconds. So the answer to part B is 8.66 seconds.
So for this stuff, you don't have to do like the breaking it off into like 25 and 3 and then all
Wait, 25 and 3. No, we want the decimal answer. Oh man, it's already over time. Here's what I'll do. For your homework, for your quiz, we'll make this nice. You will turn in to me the 8 problems that you have to graph for homework. That's the quiz. Understand? I think it's page 69 through 71, the 8 problems out of the packet. You will do all those problems on separate paper. Don't do it on the packet paper, do it on separate paper. Follow the 7 steps I did in class for each problem and turn that in. All right, that clear?
Yes, sir.
All right. Have a great day. That's due on Thursday, beginning of class. Let me turn off the camera real quick. Let me just press stop. Get it out of the way.